Welcome guys. In this video we will discuss about new and delete operators in C++ and how these operators can be used for memory management in C++. We can use the new operator to dynamically allocate the memory from heap and the delete operator to deallocate the memory back to heap. In comparison to the old C style memory management functions, the new and delete operators provide a secure and object-oriented way to manage memory. First we will discuss about the new operator. The new operator in C++ is used to allocate memory from the heap. For example, we want to allocate memory to store an integer value. For that we will call the new operator and pass integer as an argument into this new operator. So it will allocate 4 bytes on the heap like this, and it returns a pointer pointing to the start of this memory location. Now we need to assign this pointer into a pointer variable. So we will say integer star ptr equals to new integer. So this line will allocate 4 bytes on the heap and initialize the pointer ptr with that memory location. When we call the new operator, it does two things for us. First, it allocates the memory and then it initializes that memory also. As we have not provided any argument while allocating the memory on the heap, so it will initialize it with 0. Now if we try to access the value, we can do that by applying the dereference operator on the pointer. Now if we run this code, it should print 0. We can confirm this. It printed the value 0 because the new operator initialized it with the default value 0. Now if you want to initialize it with another value, we can pass it like this, say 22. Now if we run this code again, we can see that the memory on the heap is initialized with value 22 now. Now in this line we are accessing the value at this memory location using a pointer and just printing it. But if you want to change the value, you can also do that by using the same pointer and dereferencing it. When we dereference a pointer, it gives a reference to the value stored at the memory location to which this pointer is pointing. So suppose we assign a new value to it, say 77. So it will change the value at that memory location. We can confirm this by printing it, clear the console and run it again. So here it printed the value 77 because we changed the value at the memory location. Now when we allocate the memory on the heap, and after that we can access that memory using the pointer, but once it's not required, then we need to delete it. For that we can use the delete operator and pass the pointer as argument to it. It will deallocate the memory back to heap, and also make sure to assign the pointer to null after that. Otherwise your pointer will become a dangling pointer pointing to a memory location which is already been deallocated. So this is a complete example of how we can allocate a memory on the heap and deallocate using the new and delete operators. So as we already said, new operator does two things. It allocates the memory on the heap and initializes the memory also. In this case, it initializes the memory with value 22. But what happens when we use the new operator with user-defined classes? Let's see an example. We will create a class student. Now this student class has a name, string name underscore. Now we need to include the header file string for this. Clear the console. Now this student class has a variable or member variable name and the private section. Now we will add the public section. In the public section we will create a constructor. Inside the constructor we will accept a parameter and make it const, and now inside it we will say name equals to name, and we will also print a line here. Student constructor. So whenever we will create an object of class student, its constructor will be called, and we will set the given argument into the member variable name. So here we are allocating a memory on the heap for an integer, but now we can allocate a memory on the heap for an object of class student. In the brackets we will say Sumit. In this line we are allocating a memory on the heap to store an object of student. It returns a pointer pointing to that memory, and we are initializing our pointer to that memory location. Now we can create a function that will give us the name of the student. Return name underscore. Now in this line we will, let's delete this stuff. In this line we are going to access the member function of the student object using the pointer. So it will print the name on the console, and then we will call the delete on the pointer. Let's create a destructor also. So this is the destructor. We don't need any arguments in the destructor. Remove this line, and here we will say destructor. Okay. Now if we run this code, let's see what happens. So first of all, student's class constructor is called from this line. When we allocated a memory on the heap using the new operator, after allocating the memory, it initializes that memory by calling the constructor of the type which we have provided here. So in this case, it allocated a memory on the heap to store the student object, and then call the student constructor with a given argument to initialize that memory. In this case, this function is called, and it initializes the member variable with the given string value. Then we access the object using the pointer and access its member function getName, which returns the name of the student, and then we call the delete operator on this pointer. Now when we call the delete operator in the pointer, it does two things. First, it calls the destructor on the object, and then it deallocates the memory back on the heap. So first it calls the destructor. So this function was called and it printed our logs, student destructor, and then it deallocated the memory on the heap. After that, we should always initialize the pointer again with the null PTR, so that pointer is not a dangling pointer. So this is how we can use a new operator with a user defined class to allocate memory on the heap. But what if the new operator is not able to allocate the memory? In that case, new operator will throw an exception, bad alloc exception. Therefore, while allocating the memory on the heap, we should always use try catch. Now here we will put this code like this. Inside the try block, we are allocating the memory on the heap, and then we are accessing the member functions using the pointer, and then we are deallocating the memory. But in the catch block, instead of parent exception class, we know that new operator can throw bad alloc exception only. So we will catch that exception only here. So if new operator fails to allocate the memory on the heap, then it will throw a bad alloc exception, and we are going to catch that here in the catch block. So that was all for this video. In this video, we learned how to allocate a memory on the heap using the new operator, how to deallocate it, and what happens when we call the new operator to allocate memory. Like it allocates the memory, then calls the constructor, and the order is reversed when we call the delete operator. It first calls the destructor and then deallocates the memory back to the heap. So that's all for this video now. This video is a part of Pointers course in C and C++. For more videos related to this course, you can check out our playlist on YouTube, or you can go to our website thispointer.com for the complete course. Thanks for watching. Don't forget to like the video and subscribe to our channel.